Hello everyone, welcome back once more for the discussion of the topic motion. In this session, we will discuss about graphical representation of motion. First thing is, why graphical representation? See, in this session, we will understand the meaning of this graphical representation and uses. Especially, we will be concentrating on distance time graph. We have discussed about graphs in mathematics, but now here why do we use it? See, graphs are actually pictorial representation of information. Why do we have to put it in picture? That is because they are easy to understand. Remember watching a cricket match and watching the scores? See, most of the time the scoreboard, when you look at it, is very difficult to understand the whole scores one by one, to remember everything, to get a complete picture. It is difficult. But then they show the bar graph or a histogram, and easily it is understood that whether the score is increasing, decreasing, or how many wickets went in between, like red dots in between indicate wickets. Everything is understandable. Was there a patch when there was no runs? Everything can be understood just by looking at the picture. So graphs help us to understand details without remembering the numbers and exact scores. So here also the same thing will happen. Let us see how. Types of graph. So, which are the common types of graph that we use? First one is the bar graph. Bar graphs are horizontal or vertical bars which indicate the quantities of different objects. Now, here, if the distance between the bars are not given, if they are attached to each other, then these are called as histograms. The second kind is pie chart. This is helpful while comparing different parts of the total data. Here each piece looks like a pie cut into smaller parts. Third one is a line graph. This type of the ones which we find in either cricket matches that we see, even the bar graph is used, true, but this will help us to understand whether the score is increasing or decreasing. Especially in sales departments, they use this to understand whether the sales are going up or down. And the last one is the Cartesian graph. This we generally use in mathematics. This helps us to locate the position of objects. So now we will be using something like almost like the Cartesian graph, but in that we will be using line inside that Cartesian graph. Now to describe the motion of an object, we can use line graphs, but line graphs within the Cartesian product. We will be using the Cartesian axis, x-axis and y-axis, to show two different physical quantities. One physical quantity will be either distance or velocity, normally we use, and the other quantity always will be time. Here the distance or velocity will be always dependent on time, and time, since it flows always in one direction, we will be considering only the first quadrant of the Cartesian axis. The four quadrants will not be considered, but sometimes the fourth quadrant also will be considered when it comes to physical quantities which go in the negative direction, like velocity and displacement. Now here on your left side you see an example for distance time graph, where y-axis we denote distance in meters. We can also change the units into kilometers or centimeters, doesn't matter. And on the x-axis you see here time, it is in seconds, right? And this also we have maintained only because of the SI units. I have written here as meters and seconds. However, the scale can change. See, in the x-axis we have written time, but need not be always in seconds. In practical reasons we use hours also. This will be in kilometers, distance in kilometers, and time in hours also can be used. And here one more example I am taking here on your right side, that is velocity time graph. Here I have taken velocity on the y-axis, on the vertical axis, that is in meter per second. It can be in kilometer per hour also, no issues. And on the horizontal x-axis we find again time. Generally time is always taken on the x-axis, and it is not mandatory, but it is convenient. It is the convention. So first let us discuss about distance time graphs. Say the change in the position of an object with respect to time can be represented using this graph. It also helps us to take a convenient scale of choice. Example, as I told earlier, if it is required in centimeters, we will draw it in centimeters. If you want in meters, you can take it in meters. See, along the y-axis, I have taken distance traveled here, but I have not mentioned the units. But when you draw a graph, you need to mention the units of your own choice, whichever is convenient for you, depending upon the situation. And the x-axis, you always have the time. One example, a body starts from rest as shown in the point O. So let us look at the graph. Here is the graph. Look at the point at the origin. Origin is the place where the observer is standing. So we will consider it as the point O. So the body starts moving and reaches a point A at a distance 10 meters at 5 seconds. See, along the y-axis I go for 10 meters. Here we go. This is 10 meters. Horizontally, we will find a point there. Okay. And at 5 seconds, time 5 seconds. If you draw a vertical line here, they both come and meet at the point A. Right. So the timing at A is 5 seconds. Distance is 10 meters. And it reaches the point B in 20 meters at 10 seconds. So B, it is at 20 meters and it is covered in 10 seconds. It reaches C at a distance of 30 meters at 10 seconds. C at 30 meters in 10 seconds. Sorry, it will be 15 seconds. So, we get a complete picture of the movement of the body. Now, what can we do using this? What is the use of this graph? We can use the same graph to find out distance covered if you know the time. You can find the time taken for the body to reach a particular distance. You can identify that. If you know the distance, you can find out time. Or if you know both the distance and time at a position, we can find out the speed of the object at that position. So these are the three uses. If you know the time, you can find out distance. If you know the distance, you can find out time. And even if you know one of them, distance or time, and finding out the next, you can find out the speed. So let us try to find out that in the given graph now. Let me create some questions. Let us try to find the distance of the body at 10 seconds. So when the body reaches a point B after 10 seconds, see on the time graph, here is 10 seconds. Let us go and find out at the line where it meets. So then the time taken to cover 10 meters, this we are talking about the meters here, 10 meters. Okay. Then speed at 15 seconds. Along the time axis, 15 seconds. Let us see how to solve this. First, for the first question, at 10 seconds, I draw a vertical dotted line. When it reaches B, I mark the point, and from there, horizontally, I take another line. This reaches 20. So that means, in the first case, at 10 seconds, the object has reached 20 meters. So that will be our solution for the first question. Second sub question, the time taken to cover 10 meters. So now meters is on vertical axis, right? So I go to 10 meters. From this 10 meters, I draw a horizontal line till it reaches the graph, the linear graph of the motion. So it reaches at the point A. From here, I drop down a perpendicular line to the x-axis. It meets at 5. So the answer is 5 seconds. So the body takes 5 seconds to cover 10 meters. As for the third question, speed at 15 seconds. Let me see the time at 15 seconds. I'll draw a perpendicular at this point. Okay, because I need distance and time both for the formula of speed. So I draw a perpendicular, it reaches C. From here, to identify the distance, I'll draw an horizontal. And that reaches at 30. So I know the distance now, it is 30 meters. The time is 15 seconds. If I know both of them, I can use the formula speed is equal to distance by time. That will be equal to 30 divided by 15. Simplifying which, I get the answer 2 meter per second. So, see, this is an example by which we found out all the three. Distance, time and speed. So, let us continue with another example. But I am taking the same picture here for the previous example what I had taken. So, with the same linear graph, we will try to find out speeds at different distances. But this time it will not be at a point, it will be from one initial point to a final point, during which we will try to find out the speed attained by the body. Okay, let us try. Let us try to find the speed from A to B, that is point A to point B. The speed from point B to point C. Point B is the initial point, point C is the final point. Third sub question, the speed from A to C, from point A to point C. See, linear graph always indicates uniform motion, means the speed or velocity is always constant. Now let us see if the answer is almost the same. Going to the solution for the first sub question, that is between A and B. How to find out that? So here is what we do. First draw a horizontal line from A, okay, extend it, and also drop a vertical line from B. They both intersect at a point D. So now what we do is, we will consider the difference in distance. What is the difference in distance? I'll call it as S2 minus S1. Your question, what is S2? See, first we'll go to B, okay, that is the final point. We draw a horizontal line from B to the axis. We will find the value is 20. I'll mark it with a pointer. See, from B, if we take a horizontal line, it comes to 20. So the value we'll write the final distance as 20 minus S1, the initial distance. The initial point is A. From there we will check the horizontal value. How much is that? 10 meters. So that is the initial distance from the observer is 10. So 20 minus 10, that is equal to 10 meters. Okay. Now let us go to find out the difference in time. So final point is B. From there vertically if I go on the x-axis, I find the time is 10 seconds. So the initial final timing is 10 seconds minus the initial time. Initial point is A. From there I drop a perpendicular. It comes at 5. So that gives us an idea, 10 minus 5, which is 5 seconds. So AD here is denoting 5 seconds and BD is denoting 10 meters. Okay. So using these two values, let us try to find out the value of speed. So speed is always given as S2 minus S1, that is change in position of the body in meters, divided by T2 minus T1, that is the time interval. So initially we said BD, that length is nothing but 20 minus 10, that is 10 divided by the time interval is 5 seconds. So answer 10 by 5 is 2 meter per second. This is the speed of the object while it is traveling from A to B. Now let us go for second point, that is from second sub question B to C. Initial point is B this time. C is the final point. Let us try to draw the same horizontal line and vertical line. This time BE will represent the time gap, that is from 15 to 10 or 10 to 15, this gap. Okay, and CE will actually show us the distance between 30 and 20. So first the change in distance, that is from C, if you see horizontal, is 30 minus from B it is 20. 30 minus 20, answer is 10 meters. And the time interval from C, if you check on the x-axis, it is 15. So I have written 15 as the final time and B is the initial point. From there the reading is 10. So it is 15 minus 10. How much is that? 5. So BE, length of BE is nothing but 5 seconds. Now I know the distance as well as time. Then now we can find out speed. Speed is also given by change in the distance divided by, or the distance covered divided by the time interval, that is 10 by 5 again, because CE is 10, BE is 5. The answer again comes 2 meter per second, which shows that the distance the speed of the object is again same, that is 2 meter per second. Let us test now what about the speed from A to C, that is the third sub question. So to find out between A and C, let us draw the horizontal and vertical lines. They merge at F, right? So this time the distance is given by CF. Point C is at 30, F is at 10. So the distance will be 30 minus 10. Final point minus initial point. If we subtract, you get the distance covered. Then time taken. C is at 15 minutes, 15 seconds. A is at 5 seconds. So 15 minus 5, that is 10. This time again we use the formula for speed, that is S2 minus S1 being 20, T2 minus T1 being 10. 20 by 10 is again 2 meter per second. So what have we seen in this? No matter between which 2 points you take on this graph, the speed is always same. This shows the body is moving in uniform motion. A body moving in uniform motion is always shown by a straight line in the linear graph.